A tuner is a device that can transfer an electrical signal traveling along a transmission line into an electromagnetic wave that travels through free space. It can also do the reverse, receive a wave from free space and transfer it back into an electrical signal. Each concept in this glossary explains one part of how a tuner works. Dipole tuner. A dipole tuner consists of two straight conductive elements fed at the center. In a common half-wave dipole, one element is about quarter wave long, making the total length about half a wavelength. It is one of the most basic and widely used tuner in a tuner theory. A monopole tuner is a single radiating element mounted over a ground plane. A class quarter wave monopole is approximately 1/4 wavelength long and can be viewed as half of a dipole, with the ground plane creating an equivalent image of the missing half. Monopoles are widely used in wireless devices, vehicles, and other applications where a compact tuner is needed. I-FA stands for inverted I-FA tuner, while P-FA stands for planar inverted I-FA tuner. There are compact tuner designs that fold the radiating elements and use a strong connection to reduce the required physical size. I-FA and P-FA tuners are widely used in phones, wearables, and other small wireless devices. A patch tuner consists of a conductive patch printed on a dielectric substrate with a ground plane on the other side. It is low profile, lightweight, and easy to manufacture using standard PCB processes. The trade-off is that patch tuners typically have narrower bandwidth than other wire tuners. A horn tuner is a flared waveguide that gradually opens up to radiate electromagnetic waves into free space. Horn tuners are commonly used when high gain, relatively wide bandwidth, and good radiational performance are needed. They are also widely used in tuner management and calibration because their performance is well understood and predictable. A parabolic reflector tuner uses a curved dish-shaped reflector to direct electromagnetic energy into a narrow beam. A feeder tuner is placed near the focal point, and the reflector transfers the wave from the feed into a highly directional beam. Parabolic tuners are widely used for satellite communication, radar, and long-distance point-to-point. A Yagi-Uda tuner uses a driven element together with parasitic elements, typically including reflector and one or more directors, all arranged along a common bone. The parasitic elements shape the radiation pattern and produce a directional beam. Yagi tuners are a classic example of how simple wire elements can be combined to achieve higher directivity. A tuner array. An tuner array is made up of multiple tuner elements that work together by controlling the phase and amplitude of each element. Their signal can add together in some directions and cancel each other in another. This allows the tuner to shape or steer the beam electrically without physically moving the tuner. MIMO tuner system. MIMO stands for multiple input, multiple output. A MIMO tuner system uses multiple tuner elements to transmit and or receive multiple data streams, improving data capacity, reliability, or spatial diversity. Unlike a traditional beamforming array where multiple elements are often combined coherently to control the radiation pattern, MIMO system can use the different antennas as separate spatial channels. In practice, the same antenna system can sometimes support both MIMO and beamforming.